So we're trying to figure out in this problem what's going on at all of these points as far as the derivative and the second derivative. So we're looking for the sign. So remember that what we do is we're looking at two different aspects of the graph. So here this, we're assuming this is f of x, and so then our function, our derivative f prime, remember that we're looking for two things. If f is increasing, then that means that the derivative is going to be positive. If the function is decreasing, then that means that the derivative is going to be negative. So notice here that at point A, the function is going up, so it's increasing. So that means that the first derivative would have to be positive. And as far as the second derivative goes, so when we're trying to figure out what's going on with the second derivative, remember what we're looking at then is if the function is concave up, then that means that the second derivative is going to be positive. So if it looks like, kind of like that. And if the function is concave down, or in other words looks kind of like a little hat, like that, then the second derivative is going to be negative. So notice here, this guy is looking downward, like this guy, so then the second derivative is going to be negative. Okay, so now for B, notice that the function, if we're looking for the first derivative, notice that the function is neither increasing or decreasing. And if we just draw a tangent line right there, you'll notice that the slope of this tangent line is equal to 0. So right there at point B, the derivative is actually equal to 0. So the first derivative is 0 at point B because the slope of the tangent line is 0. Now the second derivative, you might be thinking, oh, well, yeah, that's 0 too because the first derivative is 0. But actually, not at all. Notice that right here, this guy is concave down. And so the second derivative is going to be negative. Okay, next one. So point C here, same thing. We look at the function and we notice that it's decreasing. And so that means that the first derivative is going to be negative. And notice that it's still concave down. So that means that the second derivative is still going to be negative. So notice that throughout these 3 points right here, the function is concave down, and so that's why all 3 of the second derivatives are negative. Now at point D, however, so at point D, when we're looking for the first derivative, that one's easy. The first derivative, since this function is decreasing, then the first derivative is going to be negative. However, the second derivative, although it's not completely clear, notice how it's concave down here, but somewhere around this area, we're just going to assume that it's D, this becomes concave up. Now remember, that's called the inflection point. So at the inflection point, the second derivative is always going to equal to 0. That's where it changes it changes concavity. So here it's going from concave down to concave up. So the second derivative is 0. And then for point E, it's decreasing, so the first derivative is negative. And now it's concave up. Notice how it's facing up now. So the second derivative is going to be positive. And so now for F, again, just like on point B, f is another flat spot. Tangent line is slope 0, so the first derivative is going to be 0. And the second derivative is going to be positive because it's concave up. Okay, and then let's take a look at g. We're running out of room here, but that's okay. We're almost finished. The function is increasing, so the derivative is positive, and it's still concave up, so the second derivative is positive as well. And then last but certainly not least, notice how the function is still increasing. It's still going up, so then the first derivative is still positive, but now it's changed concavity again, and it's actually concave down now, so the second derivative is going to be negative. So that's how you relate all three of the functions: the derivative, the first derivative, and the second derivative. So we've got that for some painkillers. The size of the dose, D, given depends on the weight of the patient, W. Thus, D equals F of W, where D is in milligrams and W is in pounds. So basically, you've got this function where you plug in W, which represents the weight, and the output is the dose. So the output is D, or the dosage. Okay, so if we want to interpret the meaning of this first one, F of 140 is equal to 120. Remember, this is weight in pounds, and this is dosage in milligrams. And so what this means is that for a person that weighs 140 pounds, their dosage is going to be 120 milligrams. Okay. So that makes sense, right? 120 milligrams. Now, the next one is not so clear. What does F prime at 140 equal to 3 mean? What's the interpretation of this? Well, let's see. This is also in pounds, but now this one is not really milligrams technically, because this is, remember, the derivative is a rate. So the units of this guy is actually milligrams per pound. So this is key to understanding what this means. Now, the other thing to remember is that the derivative gives you the instantaneous rate of change. So what this is telling you is that at exactly the point where a person weighs 140 pounds, so when a person, let's just say when a person weighs 140 pounds, then the rate at which the dosage is increasing or decreasing, but in this case it's increasing, is 3 milligrams per pound. So in other words, for a person that weighs 140 pounds, if you increase the weight, this is really important to understand, if you increase the weight by 1 pound, what happens to the dosage? What happens to the dosage? Think about it for a second. The dosage will increase by that much. Will increase by 3 milligrams. And this is a approximate because, again, this is instantaneous rate of change. So exactly at that point, this is how fast the dosage is increasing per pound. So if a person goes up to 141 pounds, then they're going to need to increase their dosage by about 3 pounds. Now, this doesn't mean that it's always 3 milligrams. It just means at exactly that point when the person weighs 140 pounds. At 150, it might be a little different. Now, again, this is an estimate, but we can use this to estimate the dosage. This is asking us for the dosage for a person with 145 pounds. And again, this is an estimate. So if we want to estimate the dosage at 145 pounds, what we say is, well, we take the dosage for 140 pounds, which is 120. And then right here we have the estimate that at exactly 140, the dosage is increasing at a rate of 3 milligrams per pound. Okay? So if you're going to increase by the weight by 5 pounds, well, then that means that you're going to have to increase the dosage about 5 times 3, or 15. Again, this is an estimate. This is an approximation, so it's not exact. This is an estimate because, of course, it could change. Okay, so then we'll estimate that this is going to be about 135 milligrams based on this rate that we have right here.